Hi students, in this video we are going to talk about polar coordinates. We're going to be converting polar coordinates to rectangular coordinates. So you've learned one method for plotting a point so far. So right now we use rectangular coordinates, okay? And if you're thinking about going from the origin, usually go left or right first, and then you go up or down. And then that's your point. And you designate this using x comma y. So that's the way we've been learning coordinates so far, rectangular. And to associate the numbers with the proper directions, again, we use parentheses or ordered pairs. Okay, and so that's the first way. The second way is to describe the location of a point using a distance at a given angle. And this would be polar coordinates, okay? So if you think about the angle, it's measured counterclockwise from the line that normally designates the x-axis, the positive x-axis, okay? And we use this angle, and it's going counterclockwise, and we also designate it with r, the distance from the origin out to that point. Okay, so we say that we're using polar coordinates when we designate the location of a point using an angle and a distance. Here, they designate it using, this is your distance, r. It's the radius of the circle that's formed with your triangle. So radius and theta is your angle. Okay, it is interesting just to note that seafarers, air navigators, and even meteorologists, they have always measured their angles clockwise from due north. So if you're ever doing an application where, it talks about landing a plane, let's say, and thinking about the crosswinds, how to change the direction of the plane so that, you're not affected by the crosswinds and you still make it to the, still make it landing safely, they're going to start it from up here, from due north, and they're going to measure their angle clockwise. Mathematicians, on the other hand, when you learn it in the books, they teach it to you here. And again, it just says for some reason that's how they do it, but they teach it to you counterclockwise, starting from the x-axis due east. Okay, so just note that because that can, get you confused if you're ever doing applications and you get your answer wrong. It's probably because you didn't start at due north and think clockwise. So that's just something to note. Okay, so we can use sines, cosines, and tangents to help us convert from rectangular coordinates to polar coordinates, or from polar to rectangular. In this particular video, we're only going to be focusing on how to convert from polar to rectangular. And so there's this example that they give us in our book, and it says change 4, that's the radius, and then the angle is 57 degrees. So they say change that to rectangular coordinates. And so I wanted to come over here real quick and show you how we do that, how this relates to the polar coordinates and how we can change them. So if we think about our circle that's formed using the tip of our triangle here, we've got a radius of r, okay? And if we think about how to describe this using sine, cosine, and tangent, we can actually figure out a way to represent x using polar coordinates and y using polar coordinates. So let's review SOHCAHTOA again, and then we'll write our formulas that we need. So again, this is just a circle that's designated x squared plus y squared equals r squared. And we're also going to think again about sine, cosine, and tangent. I'm going to write SOHCAHTOA to help us. So for SOHCAHTOA, right, if we think about the sine, using our theta, all right, we can think, okay, theta, right, is here. If we did the sine of theta, so let's do sine theta. This is like a little review for you. Sine theta would be opposite over hypotenuse. So again, looking for from theta, we say opposite, which is y, over the hypotenuse, which is r. So now, if we wanted to solve for y, we could multiply both sides by r. Okay? And then we would end up getting r sine theta equals y, or y equals r times sine theta. So that's a way to go back and forth between rectangular and polar. All right, let's do the same thing with cosine. So if we do cosine of theta, all right, then we are able to do, remember, adjacent, that's what the AH is, adjacent over the hypotenuse. So that equals x over r. And again, by multiplying both sides by r, we get r cosine theta equals x, or x equals r cosine theta. So now we have a way to convert between polar and rectangular. I'll write this, if we want to put x first, we would say x and y, right? If it's written as a point, that's going to be, so I'll scoot it up a little bit, that's going to be r cosine theta, comma, r sine theta. So now we're ready to do our example here, using our new knowledge of how to convert between them. So here we have our angle, 57 degrees, and r is 4. So if you want to know then the x value and the y value, so here's the x value, here's the y value. If you want to know how to convert this to rectangular points where you have x comma y, we're going to use these formulas right here. We're going to start with x. So x equals r cosine theta, right? And for this particular one, x equals, r is 4, okay? So we have 4, and then cosine, and our angle is 57 degrees. All right? And then for our y, it would be r sine theta, and that would be 4 sine of 57 degrees, okay? So we're going to put these in our calculator, and we're going to find these out. So for the x value, we say 4, and then cosine 57, and we get 2.18. So x equals 2.18. All right, and then we do the y. So 4 sine 57, 3.35. And again, if we want to write this as a point, we can say that's 2.18, comma, 3.35. And in your book, they like to designate R and U to indicate directions. And so you could also write this as 2.18 R, that goes with the x value, plus 3.35 U. So they like to use R and U. So just so you know, sometimes you see I and J, but just note that in this particular example, you could use R and U. All right, another example. Okay, and then this will be our last one on this video. So example 2 is a little bit different. Example 2 puts you in a different quadrant. So they want you to convert 7 and then an angle of 230 degrees. All right, so 230 degrees, so if you think about where that is, so thinking about this as the x-axis here, 230 degrees, if you start from over here, If you go 180 degrees, right, you'd be to here. And then if you go 50 more degrees, you would be at, I'm just going to draw in general, 50 more degrees would give you 230. So you're over here. If this is the first quadrant, second quadrant, you're in the third quadrant, okay? So you're in the third quadrant, and what they want, again, they want you to convert this to rectangular, and here you have your x value, here's your y value from the origin, right? It's x and y. So now we're going to convert this using our formulas. So x again equals r cosine theta, and y equals r sine theta. And so in order to do that, again, x equals our r value, our radius out here is 7, and our angle, theta, is 50. That's the reference angle, okay? This whole thing all the way over here represents 230 degrees from here all the way over to here. But we're actually going to use the reference angle, and then we'll take care of the signs afterwards. The reference angle will give us the values we need, and then we can adjust for where it's located afterwards. So this will be 7 cosine 50, and y will be 7 sine 50. So we put this in our calculator. So 7 cosine 50. And we end up with 4.5. So this is 4.50. If you want to put that, you can put 4.5, 4.50. Being as they're wanting 2 decimal places, I went ahead and put 2. And then for this one, it's 7 sine 50 for the y value. And so that gives us 5.36. And so remember, we're in the third quadrant. So think about if you were to represent that as a point, remember you'd be going from the origin, you'd be going left and down. So these are actually going to be negative, okay? Even though we got these values here, we want to make sure that we know we're in the third quadrant. So we're going to say 4.50, and it's negative, and negative 5.36, okay? And so that's how you write it as a point. If you were going to write it, using the r and the u like we did before, we would say negative 4.50 r minus 5.36 u, okay? And so that is how you convert from polar to rectangular.